We have here yet another equation that has got symmetrical coefficients. Just like the way we did in our previous video, we are going to divide through by x squared. We divide through by x squared and we get a new expression. When you divide through by x squared, it's going to become 3x to the power of 4 divided by x squared is going to give us 3x squared minus 4x cubed divided by x squared is going to give us 4x minus 14 minus 4 over x plus 3 over x squared is equal to 0. So now from this we collect like terms. We put those that are squared together. 3x squared plus 3 over x squared minus those terms that have only x minus 4x minus 4 over x, then the whole numbers alone minus 14 is giving us 0. So we factorize this out here. 3 is the common term. 3 into x squared plus 1 over x squared minus 4 is the common term here into x plus 1 over x is equal to minus 14 is giving us 0. So let us make this n, let n be equal to x plus 1 over x. So the value, we've called this n. So now let's also make this become n as well. So we square both sides for this. If I skip this, so squaring here both sides becomes n squared is going to be equal to x plus 1 over x squared. So when we square both sides here, this expanding this is going to become x squared plus 2ab plus b squared 1 over x squared. So we shall end up with our n squared will be x squared plus 2 plus 1 over x squared. For us to put this only on this side, we leave x squared plus 1 over x plus 1 over x, so this 2 comes that side. So it becomes n squared minus 2 is giving us x squared plus 1 over x squared. X squared plus 1 over x. So meaning that we have that expression as well. So what we do here is that we are going to substitute, this is x plus 1 over x, we substitute this value of n in that expression there. Then here we substitute this value of n x squared plus 1 over x, we put there n squared minus 2 here. So that our equation becomes more simpler and we find for the value of n. So we go ahead, so this is going to become 3 into n squared minus 2, which is substituting for that, minus 4 into this, which is n, that is minus 14, is going to give us 0. So now we concentrate on getting the value of n. We open brackets, formulate a quadratic equation and solve. Concentrate on getting the value of n. So after getting our values of n, we shall substitute our value of n. We put our value of n here. N is equal to x plus 1 over x. So we substitute for the value of n we've got so that we get the corresponding values of x, which are coincidentally going to be the roots of the polynomial we are trying to solve for. From our previous workings, we know that n is going to be equal to x plus 1 over x. n is 10 over 3, so 10 over 3 is going to be equal to x plus 1 over x. So we solve for the value of x. We multiply 3 throughout, and we make it a flat equation and reorganize it and get that. We end up with a quadratic equation here. Solving this quadratic equation is going to give us x. X will either be a third, or x is going to give us 3. That is when the value of n is 10 over 3. What about when the value of n is 2? So when the value of n is negative 2, so from this quadratic equation we find that x plus 1 is equal to 0. So x is going to give us negative 1, and this is a repeated. That's a repeated factor. So for our polynomial in the question, the values of x are going to become This brings us to the end of this video. Thank you for watching. For more videos, simply subscribe to Kisembo Academy. For Kisembo Academy, this is Arnold Rangakurami.